Let's talk about buffers. A buffer solution is one that has a stable pH. By stable pH, we mean its pH is not easily affected, even if it's contaminated by an acid or a base. Okay, so buffer solutions are quite important in the lab. We use it to calibrate pH meters because we want to make sure our pH meters read correctly. And so we want to make sure that the solutions that we're using to test it, to calibrate it against, would have a reliable pH. Now, these are buffer solutions are also used in reactions where you need to control the pH. The question is, why do these buffer solutions have a stable pH? The reason has to do with the fact that these solutions have a significant and comparable amounts of a conjugate weak acid-base pair. Now, comparable, by comparable we mean that the amount mole-to-mole ratio, so these are mole-to-mole ratio, of the conjugate acid-base pair is anywhere between 1:10 to 10:1. That's a ballpark figure. That's usually what we consider a buffer ratio. The best ratio is, of course, 1:1. Okay, so in other words, it's anywhere between 0.1 to 10, with 1 being the best ratio. Okay, the question is, why would it be stable if it has this? The reason is, if let's say you contaminate your solution by an acid, so your acid produces H+. Well, your buffer has a conjugate acid-base pair. So let's say the conjugate acid is HX and the conjugate base would be X-. Well, if you add an H+ contaminant, then what happens is it reacts with the conjugate base of HX that happens to be in that solution, and because you have a significant amount of that, so whatever H+ you introduce into your solution gets converted into HX. So you're not going to alter the concentration of H+ significantly. Similarly, if you contaminate it with hydroxide, this time it's going to be the HX, okay, the conjugate acid here, that will react with that hydroxide and convert the hydroxide into water. Okay, the H plus HX combines with the hydroxide to give you water plus X-. So in either case, you don't get to see a significant change in the H+ and the hydroxide concentration, and so that leads to what we would consider a stable pH.